Hello again, welcome to Mastercam course. In that lecture we're going to talk about the C-axis example by using the Mastercam 2024. You can see that I created my model actually by using the SolidWorks, and after that I just need to save my file with and actually extension with the SolidWorks, and then I just need to turn to the Mastercam. I just need to activate the all files. And then I just need to double click on my SolidWorks part, and that's it. You're gonna see that, and my product is ready right now. And after that, actually this is the Toolpath Operation Manager page. This is empty right now. We need to turn to the machine section, and then we need to turn to the lathe and default machine. And after that, you can easily see here, and we can get our stock setup and the other stuff here. Actually, I don't want to focus on the stock setup and also chuck properties here. Let me turn back to the actually roughing process. So this is the actually the lathe toolpath and the roughing operation. So when we turn to here, this is the actually solid selection active right now. So I just need to select this line and end off to my actually last entity, and I need to select this line. So we're gonna create our toolpath starting from the green arrow to red arrow. So I just need to turn to here to select OK button, and then of course this is my tool number, this is my tool. Actually it is actually created according to my product. So let me click here. You're gonna see that all my toolpath is created automatically. Of course, if you would like to turn to parameters, you can easily change all your parameters here. Actually, before that, you can also turn to here. We are working on the int system right now. Okay, if it is okay for you, no problem. You can turn to here. You're gonna see all the radius and feed rate and other stuff is calculated by using the inches system. If you intend to change that stuff, actually you need to turn to here and configuration page, and you can turn to the start position, and then you can turn to the millimeters approach as a current and actually configuration file, and then you can click here to save, and that's configuration file, and then actually you can hit the OK button to turn to millimetric system after that. Let me hit here, and if you would like to scale your part, you can easily scale your part, but I don't want to see, and I don't want to scale my part. Let me turn back to here, and we can create some edges here, and then we can analyze that edge. You're gonna see that this is the 3-point and something and system here. So you can see that that's not okay for us. We need to scale it. Sorry. And we can use the delete all that operation, and maybe we can also delete that product. Okay, we are working on the millimetric system right now. After that, we can use the open file options, and we can double click on our product, and then that's fine. This is the millimetric system, and this is my product. Let me create some curve here, and then we can select this one, and we can use the analyze it. You can see that this is the 100 millimeter diameter. Okay, let me turn to the top view. We can turn to the machine, lathe, and default machine, and after that I can use the right mouse button, lathe toolpath, and the roughing operation. And according to my solid selection, I can start from here to here, and then I just need to hit OK button to see my toolpath. So you're gonna see that all my radius and other stuff is and according to millimetric system right now. This is my tool 1 with the radius 0.8 millimeter, and this is my actually parameters for compensation type. And then we can easily organize our feed rate, and we can also use actually constant RPM with 2000. So if you select the constant RPM, you don't need to write your maximum spindle speed, but of course you can also write the same as with your spindle speed. And after that we can also organize our reference position, and with the Z position can be 2 mm. For retract also can be selected as a 2 mm. I just need to hit that button here. This is my approach position and this is my retract position. After that, let me turn back to rough parameters. We're gonna see the actually different type of and the depth cut options. Most of the time we prefer to use the equal steps here. Equal steps and depth of cut can be 1 mm. Okay, this is the half of my diameter. It means that we're gonna cut 2 mm, and the 4 and according to my diameter we're gonna cut 2 mm. Okay, you can also activate overlap options. Overlap options is and quite important for and that's kind of degree operation. If you would like to see, if you would like to don't see and the some steps here, you can easily select overlap options, and when you activate that or non-activate that, you're gonna see the that's kind of steps here. Okay, most of the time I prefer to activate overlap options. Okay, this is the stock to leave on the x-axis, stock to leave on the z-axis. This is the entry amount, it can be 1 mm. This is my roughing direction. Okay, it's okay. This is my cutting method, it can be one way, zigzag straight, and zigzag downward is also another and options. Okay, this is my compensation type. It's going to be calculated by the computer. Okay, we can compensate, we can see the some compensation according to my direction. It's going to be on the right side. So when we turn to my tool options, double click on my tool, we're going to see the some compensation type here. This is my compensation type. Okay, so we can also organize our lead in and lead out process. This is my lead in process. While we are entering our process, we're going to use the that direction with 1 mm. This is the lead out. It can also be 1 mm for and the that direction. Okay, we don't wanna and hit that button. Actually we cannot see any and the pocket here, so that's why we don't need to select any of them. So if you have that kind of and grow figure in your product, actually you can also be and consider that stuff. Anyway, let's hit OK button according to my parameters. And when we hit the geometry, according to this geometry, starting from here to here, and we can create that kind of toolpath here. This is for roughing process. And after that, I can turn to the lathe and finish operation. Okay, we can also start from here to here and hit the OK button. And then let me change my tool. Okay, I can prefer to use the different radius here, 0.4 mm with that feed rate. This is my station number 2, and I can prefer to use constant cutting speed. So when you use the constant cutting speed, it means that we're gonna change our spindle speed. So that's why we need to write here maximum spindle speed here. Okay, this is my constant and the cutting speed, and this is my spindle speed. My spindle speed is going to be calculated according to my diameter. Okay, if you don't have any idea about that stuff, you need to turn to actually previous lecture and try to understand better what is the constant cutting speed and constant spindle speed approach. Okay, let me activate my reference point here. I just need to turn to the Z position, and then you can also organize your home position. I don't want to use any of them, but you can use the from tool from and the machine and user defined, and you can also organize that kind of stuff in your post processes. Okay, let me turn to here. This is the finish parameters. Okay, this is the number of finish passes. We're gonna only have one, and the finish passes, so we don't need any and step over here. This is the stock to leave X and stock to leave Z axis. And you can also see that this is the lead in and this is the lead out approach here. We don't care about actually and the plunge parameters, just calculated. You can also see here my compensation. It's also calculated by the computer, and we're gonna be on the right side. How can I decide it? And we're gonna be on the right side. This is my geometry. According to that perspective, we're gonna be on this side. So this is the right. Okay. So that's it. This is the roughing and finishing process. After that, you can also see here some and the Z-axis operation. So let me create some curve here. Okay, this is my circle. We are working on the 3D, and we can create our circle like this, and then we can easily transform it by using the translate options. This is actually y-axis. I just need to write y-axis. We can, let me turn to actually as a weave options. We can turn to the wireframe, and let me organize my, yeah, I think that's enough. This can be 32. So that's it. Let me turn to clear color and right mouse. Okay, let me turn to here and lathe operation and Z-axis operation. Okay. Okay, we can use the right mouse button, Mill Toolpath, and the Z-axis and Z-axis drilling operation. I just need to select that point and hit the enter button, and then that's it. Let me turn to here to create my tool. I can create my tool. This is my tool, and it can be actually 10 millimeter. I don't, and remember the diameter. Okay, let me create 6 millimeter diameter like this one. Okay, and this is my spindle speed actually. Let me turn to here. This is my drilling operation. Cycling process is normal drilling GE81. Then let me talk about link parameters. Incremental clearance plane 5, lead track 2, and top of stock 0, and depth. This is the incremental according to my geometry, and we can hit the select point. We can turn to the wireframe and select this point. So actually, yeah, we're gonna calculate our actually point according to and select point options. Okay, actually it must be minus 32 anyway. Okay, so I think that's enough. And you can also see the new approach here. This is the clearance plane and the retract position. And you can also see the top of stock and the depth operation here, and everything seems and more clear than the previous one. Oops, sorry. We need to organize our rotary axis. Rotary axis diameter can be also and 32, and we're gonna see our and the link operation. Of course, we just need to turn to here. Actually, we need to analyze our diameter. Yeah, it can be 12 millimeter diameter. We can turn to the tool operation, and we can turn to the edit tool options, and then we just need to change the diameter. Actually, we don't need to change it actually. Okay, there is no any change about our and the toolpath, because this is the drilling operation, so we cannot see any and the reduce compensation here. And okay, that's it, and this is all about our example.